In the vast and complex tapestry of life on our planet, a new form of intelligence is beginning to emerge. It is not born of flesh and blood, but of silicon and code. We call it artificial intelligence, or AI. At its heart, AI is the remarkable ability of a machine to perform tasks that would normally require human intelligence. Think of a computer that can recognize a face in a photograph, or a program that can translate our words from one language to another. These are wonders of the modern age. These systems are specialists, honed and trained for their single, dedicated function. But this specialized intelligence is just one part of a much grander story. Scientists and dreamers alike look towards a more distant horizon, towards something they call artificial general intelligence, or AGI. This is a profoundly different concept. An AGI would not be a specialist. As its name suggests, it would be a generalist, possessing the ability to understand, learn, and apply its intelligence to solve any problem, much like a human being can. To understand how these artificial minds are brought into being, we must look at the fundamental processes that allow them to learn and grow. The primary method is a field known as machine learning. It is a beautiful concept, elegant in its simplicity. Instead of providing a machine with a rigid set of rules to follow, we provide it with vast amounts of data and allow it to discover the patterns and rules for itself. Within the vast domain of machine learning lies a particularly powerful and biologically inspired approach called neural networks. These are computational systems modeled loosely on the intricate web of neurons in the human brain. Let us consider a simple, tangible example. Imagine we want to teach an AI to distinguish between apples and oranges. Instead of writing rigid code, we would show it thousands of pictures of each fruit correctly labeled, allowing the computational power of the AI to configure the rest. Just as a biologist needs a microscope and a geologist needs a hammer, the architects of artificial intelligence rely on their own specialized tools. The creation of these complex systems is not done from scratch each time. The dominant language in the world of AI today is, without a doubt, Python. Its popularity stems from its relative simplicity and readability, making it accessible to a wide range of individuals. Among the most vital tools in this ecosystem are the deep learning frameworks. Two titans stand out in this landscape: TensorFlow, developed by Google, and PyTorch, championed by Meta. Within the world of AI, certain designs prove to be exceptionally effective. One of the most transformative is an elegant design known as the transformer architecture, which has become the bedrock of nearly all modern large language models. The genius of the transformer lies in a mechanism called attention. For example, in the sentence, "The robot picked up the red ball because it was heavy," the attention mechanism helps the AI understand that it refers to the ball, not the robot. Another powerful design is the mixture of experts, or MOE. This architecture is built on a wonderfully intuitive idea. Instead of having one massive neural network try to learn everything, why not have a collection of smaller, specialized expert networks, each as master at its particular task? Every great scientific pursuit is propelled forward by curious and dedicated individuals. In the rapidly evolving landscape of artificial intelligence, one of the most influential explorers of our time is Matt Deitke. His journey into the heart of AI was not a straight path, but one driven by a deep-seated curiosity about how intelligence works. He began his academic life at the Georgia Institute of Technology, where his early interests spanned both computing and biology. He saw that much of AI research was focused on disembodied minds, trained on text and images from the internet, but with no real connection to the physical reality those words and pictures described. He argued that true understanding could not be achieved by passively observing data. An intelligent agent needed to act in an environment to push, pull, and see the consequences of its actions. It needed to have a body, even if a virtual one. One of his most celebrated early projects is Molmo, a framework built upon the popular game Minecraft. He and his team recognized that Minecraft was more than just a game. It was a complex, open-ended world with its own physics, resources, and challenges. Building on this success, Deitke led the development of Procthor, a revolutionary platform for embodied AI research. ProcThor can procedurally generate thousands of unique, interactive, three-dimensional indoor scenes. To populate these rich worlds, Deitke and his team created another landmark resource, Objaverse. This is an immense, open-source dataset containing hundreds of thousands of three-dimensional models of everyday objects. Perhaps one of the most imaginative projects is Phone 2 Proc. This astonishing tool allows a person to simply walk around their own home, capture a video with their smartphone, and have an AI automatically reconstruct a fully interactive, three-dimensional digital twin of that space. At the heart of Matt Deitke's work lies a powerful philosophy. He posits that intelligence cannot be divorced from experience. An AI that only reads text can become brilliant at manipulating words, but it will never truly understand what a heavy box is until it has tried to lift one. This philosophy extends to multimodal AI. Humans do not experience the world through a single sense. We see, hear, touch, and move through our environment all at once. Our understanding of a barking dog is a rich combination of sound, sight, and tactile memory. He's trying to get AI to learn in the same fundamental way that a child does. A child learns about gravity not by reading Newton's laws, but by dropping a toy and watching it fall over and over again. In mid-2025, Matt Deitke made a significant move, leaving his co-founding position to join a newly formed group at Meta. This was not just any corporate research lab. It was a team with one of the most ambitious goals in all of science. His decision to join Meta's Superintelligence Lab, led by the renowned AI scientist Yann LeCun, was a powerful statement. It demonstrated a belief that the path to AGI would be paved with embodied, multimodal, and interactive learning at unprecedented scale. Meta, with its vast computational infrastructure and strategic focus on virtual and augmented reality, the metaverse, provided the perfect environment to pursue this vision. Here, the simulated worlds he had helped pioneer could be built on a scale previously unimaginable. The influence of Matt Deitke extends far beyond his individual contributions. He has helped to steer the entire research community, shifting the conversation towards the critical importance of interaction and physical grounding in AI development. Projects like ProcThor and Objaverse are not just impressive feats of engineering, and they are enabling technologies. They have lowered the barrier to entry for high-quality research in embodied AI, allowing university labs and smaller teams worldwide to conduct previously impossible experiments. An AI trained in the diverse interactive environments that Deitke champions will be better suited for real-world applications. From household robots that can safely assist the elderly to autonomous systems that can navigate complex environments. As we stand today, the field of artificial intelligence is advancing at a speed that is both exhilarating and daunting. The development of AGI is not just a technical race, and it is a profound responsibility that requires foresight, collaboration, and a global conversation about the future we want to build. Ultimately, the story of AI is a human story. It is a story of curiosity, of our timeless quest to understand the nature of our own minds by attempting to build new ones. Individuals like Matt Deitke are not just engineers. They are explorers navigating one of the last great uncharted territories of science. Thank you so much for watching. If you enjoyed the video, please hit the thumbs up and subscribe to the channel to stay updated on all things numerical and financial. Thanks again, and until next time, stay calculating, my friends.